Good morning, everybody. My name is Sankar Karmaker, Assistant Professor, Department of IT. Today, our topic is to design and construct half adder and full adder and verification of IC gates, and that the half adder will be designed by IC. And if we first topic is we implement the IC with IC half adder in IC level. So that for that design happened we our requirement our apparent required that the AND gate, XOR gate, NOT gate, OR gate, and IC kit like trainer. So for the IC specification for AND gate is IC number 7408, and next for XOR gate the IC number is 7486. Also for NOT gate IC number is 7404 and OR gate is IC 7432. And the half adder mean that the to perform the addition of two binary single bit number, and if we perform the addition we will get the sum and carry. So half adder mainly perform to bit single bit addition, if and we represent sum for S and carry for C. Next, to design, suppose input, two variable input for half adder, and we will get the output is sum and one for sum and one for carry. For two input variable, maximum combination for two input is 2 to the power 2. I mean 2 to the power n. N is the number of bit. Here the number of bit is 2. So 2 to the power 2 mean 4 combination can be possible. What is 0 0, 0 1, 1 0, and 1 1. And for the sum, as the binary addition, we already performed in the previous classes for binary addition. So we know from the binary addition is for 0 0 bit, if we perform the addition of binary bit to single bit 0 0, that will be output of sum is 0, carry for 0. And if the input value is 0 and 1, that means A for 0 and B for 1, we will get sum is equal to 1 and carry 0. And min term for sum, for 0 1, we will get A bar B. And again, the input value 1 0, A for 1, B for 0, and the sum carry sum is equal to 1 and carry is equal to 0. So that the output of sum for 1 0, the min term is A B bar and carry is equal to 0. If the input value both A and B is equal to 1, the sum is equal to 0 and carry is equal to 1, and for the carry min term is AB. So for the Boolean equation for the sum, for the column of sum, we will get S is equal to A bar B plus A B bar, that is the XOR gate, and carry is equal to A B, that is the min term of AB. So we will get the Boolean expression for sum and carry is equal to AB. So that AB is mean A dot B, that is the AND gate, that will be recurred for AND gate. Next, the circuit diagram for the half adder, that is the A B is equal to sum, which is sum is equal to A bar B. We require the XOR gate A bar B plus A B bar, that is the XOR gate, and carry is equal to AB, that is one AND gate will be required to implement the circuit of the half adder. And the IC number, you already know that the IC number is for XOR gate is 7486, and the for AND for carry the IC number will be required 7408, that is the AND gate. So if we implement this gate level, I mean for AND IC, that is the 0 0 0 1 1 0 1 1 for the AND operation of the Boolean expression for AND gate. And the pin diagram of this IC AND gate 7408, which is A2, that means in one IC now 4 number of AND gate is there. So for the input value 1 2, and we will get that total number of pin is 14. 1 2 3 4 5 6 7 8 9 10 11 12 13 and 14. So 7 is always for ground. When we implement this in lab, so 7 always be connected with ground input, and 14 VCC 14 is connected as the power supply, that is 5 volt power supply will be connected and will be recorded. That 1 2 is the input value, 3 is output value. Next 4 5 is the input value, 6 is the output value, and 8 is output here in the next gate, and 9 10 is the input value, 11 is output, 12 13 is the input value. So This is the pin diagram of the AND gate. So XOR gate, again we implement the IC of XOR gate, that is the 7486 IC number, A bar B plus A B bar, that is the 2 input AB, and we will get the output Y is equal to A bar B plus A B bar. So that is the truth table of the XOR gate, that is 0 0. The input value 0 0, we will get the output 0, and 1 1 will get the 0, and the two opposite input, that is 1 0 1 and 1 0, it will be get the output value is 1. And the IC, in this IC for XOR gate, 4 gate are there in one IC, that is 1 2 is the input value, 3 output, 4 5 is the input, 6 output, 7 is the ground, connected with ground, and 8 is the output, 9 10 is the input value, 11 output, 12 13 is the input, and 14 is the DCC 5 volt current supply will be connected for the pin number 14. So this is the pin diagram of the IC XOR gate. So what is the application of half adder? Half adder application mainly basically used for the arithmetic logic unit to perform the any kind of arithmetic operation. The half adder will be required for only 2 bits, only single 2 bits. Half adder is also used to make full adder, as the full adder requires 3 inputs, the third input being an input carry. So we will be able to cascade the carry bit from one adder to other adder. So this is the application for half adder circuit. So again, to design and construct full adder circuit and verify the truth table using IC or gate levels. Okay, so that will require for implement the full adder. That, so one thing we have to discuss, that there is the limitation for half adder, that the consecutive more number of 2 bits cannot be performed for addition, because there are, if we perform the 2 bit adder, 2 bit to single bit addition, we will get the sum and carry. But more than 2 bits, if we perform the addition, that will be limitation for half adder. That in that case, we have to record the full adder circuit. The full adder circuit apparently record that the AND gate, that IC number you already know, as we define in the half adder 7408, XOR gate 7486, NOT gate 7404, and the 1 OR gate will be recorded, that is 7432, and the trainer kits, that the breadboard will be recorded. Okay. The full adder already we define that if more number of 2, that means 3 bit number can be performed for the full adder will be recorded, and we will get the output as a sum and carry. So maximum input is 3, that is A, B, and carry CR. So 3 bit 2 to the power 3 mean 8, that is 0 to 7 is the input value, and we will get the sum and carry. So corresponding, if we perform the sum, and we will get the sum and carry. So if the in each row, if there is the more number of 1, that means if the number of 1 in each row is 2 or more number of more than 2, then the output will be carry will be 1. Always carry will be the 1. Carry will be generated if in each row there is more number of 1. I mean, if the number of 1 is 2 or more than 2, then carry will be generated. So this is the truth table for full adder. Okay. Now to design this full adder, if we see that the corresponding sum and carry will be get for performing the addition of A, B, and C here, carry, then we will get the sum. The sum for 0, we will get first row 0, second row 1, and 1 0 1 0 0 1. So that for first row we will get sum is equal to 1. In that case, if we implement this all truth table using the K map, we will get the sum, and the sum is equal to the Boolean equation of the sum is equal to H is equal to A bar B, A bar B bar C plus A bar B C bar plus A B bar C bar plus A B. That is the XOR gate. That will be, if we implement, if we minimize this one, we will get sum for XOR gate, and carry is equal to C is equal to AB plus BC plus C. So this is reducing by the K map, using K map. So this is the circuit diagram. You see, this is the circuit diagram. S is equal to A bar B bar C bar, and carry is equal to AB BC C. So this is the gate level in pin diagram of the IC. That is 1 2 is the input, 3 is the output, 4 5 is the input, 6 is output, 7 is ground, and 8 is output, 9 10 is the input value, 11 is the output, 12 13 input, 14 is the DCC 5 volt in diagram. So this is the 4 bit parallel adder. If you can implement, that is C input and corresponding A, B, and sum, with the input and corresponding full adder output, and at the end of the port ripple count ripple ladder we will get the output. This is the user of full adder. So the basic building block of the chip on chip libraries. For another is in processor and other kind of computing devices adder are used in the arithmetic logic unit. Adding another useful uses of adder also used in other parts of processor where they are used to calculate addresses, table indicators, and similar functions. So this is useful of full adder. So in this way, you can implement the half adder and full adder in our lab experiment. Thank you, everyone.